Hi children, today's class 9th class physical science and we are discussing about laws of motion. Laws of motion. In this laws of motion we already in previous session we already completed regarding first law of motion, second law of motion. Now we are discussing regarding third law of motion. Newton's third law of motion. Now before going to Newton's third law of motion, let us discuss some examples where we will see we will see the application of this Newton's third law of motion. Newton's third law of motion. See. Now if I beat this board like this, can I get hurt? Yes, definitely I will get hurt. Why I will get hurt? Whether I am beating this board or board will returns beat me, it will beat to me. I am trying to beat this board. If I am trying to beat this board, why I will get hurt? That's the question. Okay. When I beat like this, I will exert force on the board. I will exert force on the board. Then board will keep quiet. No. Board in turn will apply reaction force on my hand. And with how much force I applied or I bet this board, the same amount of force board will apply force onto me. That means now I am exerting force on the board. The force exerted by my hand and the board is action force. In turn, the board is applying same amount of force on my hand, which is known as a reaction force. So, what is Newton's third law? For every action, there will be equal and opposite reaction. For every action, for every action force, there will be a equal and opposite reaction. Equal and opposite reaction. This is known as Newton's third law of motion. That means action force will be applied by the first body on the second body and the reaction force will be applied by the second body on the first body. Now, means action is applied in one direction, reaction force is applied on the other direction. So, this Newton's third law of motion can also be stated as action and reaction forces are paired forces. Paired means they will act as a pair. But on same surface, two forces won't be applied. Here action force is applied by the first body on the second body and reaction force is applied by the second body on the first body. That means on same body both action and reaction forces won't be exerted. So in this way we have a Newton's third law of motion. Let us discuss elaborately with few examples. Now when we do swimming, what we will do? We will try to push the water backwards. That is nothing but a action force exerted by us on water. The water will keep quiet? No. Water will apply reaction force on us in opposite direction. As a result, we will move forward. We will advance forward. So, force exerted by us pushing the water backwards is nothing but a action force. In turn, the water will apply reaction force on us. As a result, we can able to forward, we can able to advance. That means in swimming, while doing swimming, we can able to forward or we can able to backward. How? Because of action reaction forces. Similarly, birds will have a wings. When they spread the wings, the area covered by the spring wings will be larger. With a larger area wings, they will push the air backward, downwards. Then air will in turn will apply upward force on the bird's body. That's why birds can able to fly. Then why can't we fly now? Why can't we fly? Because the area of our hands is very less. So how much what you call the force we are exerting on air, Same force will be exerted on us by the air in upward direction, but the force acting on us in upward direction is less than our body's weight. That's why we are unable to fly in the air. So birds what you call this weight will be very less compared to the what you call the weight of the air pushed by the bird's wings. Then as a result, upward force acting on them due to reaction force of air is greater than their body's weight. As a result, birds can able to fly into the air. So the force applied by the bird's wings on air, pushing the air downwards, is due to the action force of the birds on air. Then air will apply reaction force in upward direction. Due to that, they can able to fly. So that is also because of Newton's third law of motion. And we already know that rockets can able to eject into the atmosphere. What we call because of Newton's third law of motion only. Rocket will have a two chambers. Here it will have what we call satellite contains satellite chamber. Satellite carries a chamber, and it will inside it will have a two chambers which are what we call interlinked with two what we call these pipes. Then it will have a valve, open valve, nozzle. Through this now this one will be filled with fuel and one will be filled with oxygen. This fuel generally burns in presence of oxygen and it starts ejecting gases with a greater force in downward direction. It going on eject gases with a huge force in downward direction. As a result, what will happen? The air will apply what we call reaction force on the rocket in upward direction. Then rocket can able to fly into the air. This is also due to the Newton's third law of motion. That means action is equals to minus reaction. Action is equals to minus reaction is nothing but a Newton's third law of motion. So what is Newton's third law of motion, children? For every action, there will be a equal and opposite reaction, or else action force is equals to minus. Why minus we are indicating? Because it is acting in opposite direction. That's why action is equals to minus reaction. Now let us go for some more examples what we call which we can able to see in our daily life. Now we can able to walk. We know that if I drop this chalk piece holder, it will freely fall onto the ground. Why it will fall? Because of gravitational force. Now, gravitational force means Earth's gravity is going on attracting the chalk piece holder in downward direction. Then when it will fall onto the ground, it should struck to the earth, na? But if it falls onto the ground, I can able to what you call lift the chalk piece holder without doing any huge effort. Why? When it falls, it will apply action force on the ground, and the ground in turn is going on applying reaction force. That's why it won't struck to the ground. Easily we can able to take out the chalk piece holder. Now when I will take out the step and what we call when I go for one step forward on the earth, then my leg has to struck to the earth because of gravitational attraction. But how I can able to take out my what we call my leg and go for next step, or how I can able to easily run and easily walk? Because whenever we are stepping off, stamping on the earth, we are applying action force. Then earth will apply reaction force. With that, what we call without much effort, we can able to take out our leg and we can able to walk and we can able to run. That means because of action and reaction force, because of Newton's third law of motion only, now we can able to walk and we can able to run. So in swimming pool also already said, about birds I said, about rocket also I said. Now whenever what we called this military campaign or gun shooting is there, they will we need training for the what we call shooting of gun. Why? Whenever what we call the bullet will be fired out from the gun, bullet will apply huge force on the air, then air will apply reaction force on the gun, then gun will be recoiled. Gun will be recoiled means it will come backward. then that's why we should not keep what we call gum in front of eye, and if we shoot, then it will come, it will recoil and be damage to eyes. That's why whenever they will show this firing scenes in the films or anywhere, they will keep the guns in what we call nearby shoulder, because when the recoil of guns will occur, the shoulders can able to bear that much what we call force. So whenever the fire bullet will be fired from the gun, it will apply action force on the air, then air will apply reaction force on the what you call this gun, then the gun will be recoiled, come backwards. Similarly, what you call, you might have saw the what you in Bahubali picture, there what you call, you might have used that wagon, when wagon means Pirangi. In that what you call, they used to place one shell, Mandu, and they used to fire that one, and that huge shell will what you call eject out by applying action force on the air. Then as a result, that whole wagon will recoil. So that is also because of action and reaction forces. Now, whenever there is fire accidents occur, then the fire, what you call firemen. Firemen means who what you call bring the water and of that fire engine, and they will try to what you call put off the fire. Then they will catch a just what you call that mesh pipe, that huge what you call that pipe, which consists from through that huge water will flow, and they, with the huge force the water will eject out. Then it is not that much easy to hold that pipe, because of the action applied by the water on air. Then what you call the air is going on applying what you call recoil force, reaction force on that pipe. Then that is not easily to hold that pipe, it will going on come backward. So they need a training for holding that and for properly and for fastly, and as a result they can able to what you call put off fire. So all these incidents what you observed, for every action there will be equal and opposite reaction. For every action there will be equal and opposite reaction. This we will call it as Newton's third law of motion. Newton's third law of motion. So in that way, what we call Newton's third law of motion also can be stated as action force will be applied on one surface, reaction force will be applied on another surface, but action reaction forces will be applied as a pair. Pair means jata, but they won't be applied on the same body. The action reaction forces are applied on two different bodies. Here, if I apply what we call it this force like this, then action force be applied by my hand on the board, and board is applied reaction force on my hand. That means action is applied to the board and reaction force is applied to the my hand. Similarly, when the birds are flying, then the action force is applied by the bird's wings on air, then air will apply reaction force on the bird's body. So action is force applied by the bird's wings on air, and reaction force is force applied by the bird's wings on air, on bird. So their action reaction force are not applying on same body. Similarly, while swimming also, we will push the water by applying action force. Water will kick you front, what we call by reaction force. Similarly, in rocket also, when the gases eject out, they will apply action force on air, and the air will apply reaction force on rocket. But both the forces are not applying on the same surface, on the same body. Similarly, what we call recoiling of a gun, there the bullet will apply action force on the air, and the air will apply reaction force on the gun. But both forces are not applying on gun. Similarly, when fireman catches that pipe with the huge when the water eject out, it will apply action force on air, and air will apply reaction force on pipe. So both the forces are not applying on same body. So in this way, we can able to state that for every action there will be equal and opposite reaction. For every action there will be equal and opposite reaction, or action and reaction force are applied as a pair, or we can say that action force and reaction forces are applying on two different bodies, but both the forces are not exerting on same body. Both the forces are not applying on same body. That we can able to prove with one experiment which proves the Newton's third law of motion. Now how we can able to prove Newton's third law of motion? Means we have to take one test tube. We have to take one test tube. First of all, you have to take one retort stand, and we have to take one support stand. For this support stand, you take one what you call test tube. Test tube should be arranged in a vertical, in a slanting position with the help of a with the help of what to say, this thread. The help of this thread, with the help of a thread and what to call the help of a rope, we will place this thread in a slant position, and it is filled with slightly water. It is filled with slightly water, and next it is closed with rubber cork, tight rubber cork, tight rubber cork. Now, with the help of a spirit lamp, or with the help of a, now spirit lamp only better. With the help of a spirit lamp, gently heat, gently heat. Now, we should not heat water, we should apply huge amount of heat. Gently we have to heat. Now, if you going on gently heat, after a little bit extent of time, we will observe that this rubber stopper will eject out in this direction. Will eject out in this direction. Then immediately we can observe that this test tube move backward. It will move backward. Now, why that this rubber stopper will eject out? Whenever we started heating this water, water will become hot water. When we know that when you heat water, it starts expanding. It starts expanding. When it starts expanding, it will boil and it want to occupy more space. As a result, it will apply force on the rubber stopper, and rubber stopper will eject out with a force. That means water will apply, means vapor will apply, this water or water vapor will apply action force on the rubber stopper, then rubber stopper will eject out due to the action force applied by the water vapor, and as a result then air will apply reaction force on this test tube, then the test tube will move backward. That means the ejecting out of this rubber stopper is due to the action force, and the movement, the backward movement of test tube is due to the reaction force. In this way, we can able to show action force and reaction force. And if we see the directions, action force is in this direction and reaction force is in opposite direction. And action force is applied on the rubber stopper by the what we call water vapor, and reaction force is applied on the test tube by the what we call this air. So we can see, so in that way we are showing that with how much force this rubber stopper will eject out, with that much force the test tube will move, it will move backward. And that's why the movement of test tube is due to the reaction force, the movement of this rubber stopper is due to the action force. And if you observe, action force and reaction force are not applying on the same body, and action force and reaction force are applying on two different bodies, and they are also applying in two different directions. In that way, we can able to demonstrate Newton's third law of motion, which we will call it as for every action there is a equal and opposite reaction, or action and reaction forces are applying as a pair, or we can say that action and reaction forces are applying on two different objects, or we can say that action and reaction forces are not applying on same body, they are applying in two different objects. And also we can prove that action and reaction forces are opposite in direction. Action force is applied in this direction and reaction force is applied in opposite direction. In that way, we can able to demonstrate Newton's third law of motion. The movement of this rubber cork is due to the action force applied by water vapor on rubber cork. The movement of test tube is due to the reaction force applied by the rubber cork on test tube. In that way, we can able to demonstrate for every action there will be equal and opposite reaction, or action and reaction forces are occurred in a paired position, or action and reaction forces are not applying on same body. Thank you.